Hello guys, good evening, good evening, good evening. Good evening guys. Okay, so just give me a moment. Let me just check our audio and video quality. Then yes, we'll start our session. So just give me a moment before we proceed. So meanwhile, if you have any doubts, you're always free to ask. Yes. Hello. Hi Adya. How are you? Yes. Yes, perfect. Okay. So we can start our session now. Shall we start? Okay. Let's go ahead. Hi, I welcome you all on Let's Crack JEE English channel, and this is our lecture number 7 on permutation and combination. So we'll move ahead now. Hi Mithilesh, how are you? Okay. So this is my small introduction. Hi, this is Nishant Khanduja. I graduated and post-graduated from IIT Bombay. My rank in IIT was 1256. In AIEEE it was 363. In Rajasthan pre-engineering test it was all India rank 4. I traded in US and Canadian markets for 2 years. I also have 8 years of teaching experience. And why I became teacher, if you want to know the reason, so the reason is very simple. It's like this is something personal that I always wanted to share my experience with students, those who are preparing for JEE, that how to prepare for JEE when you are not going to any coaching institute. Because I didn't go to coaching institute, so I know the tricks. I know the way. How you can crack it if you are not going to any coaching institute. What you need to focus upon. So whatever findings, whatever observations I made, so I always wanted to share all these things with people who are going through the same thing which I had gone through. Okay, so all these, so I always wanted to do that. Now the thing is, by which channel? So now I found this Unacademy. So Unacademy became the reason, or Unacademy became the medium, the license between me and you, so that now I can come to you and teach you guys. So I associated with Unacademy with their India's largest campaign, that is Crack IIT JEE. Okay, and now the thing is, see, I want to teach you guys. Now the thing is, if you guys want to learn from me, then what you need to do? You need to install Unacademy Learning app. When you install this Unacademy Learning app, you get two sort of options. One is called your Plus subscription. Another one is called your Iconic subscription. Okay. So in Plus subscription, what do you get? You get to attend daily live classes. So these daily live classes are what? So these are better than your YouTube live classes, because the kind of experience, the kind of interaction you're going to have with the educator, that is remarkable. Can't even compare with YouTube live classes. The kind of the kind of environment you will feel, that is you can consider that as next to offline classroom experience. The way we used to attend our classes, we used to interact with the educator, we used to just educator used to ask questions, we used to answer those questions. So everything is here. So those asking questions, so there is a poll system on the platform. So educator creates poll, you just mark the options, he sees, then he will tell you what to do, what not to do. So these are the brilliant things are there in those live classes. You can also attempt live tests and quizzes. So for say, if you feel like that you want to evaluate your preparation towards any topic, so you can just attempt live tests and quizzes, and in that case you can figure out what is to be done, what not to be done. You also have options to attend structured courses by top educators. What I mean to say is, let's say if you come to know that there is a really good educator, he's from Indore, and you are there in Bombay, but you can't go to Indore, but you want to learn from him. So that guy is there, that educator is there on the application with his structured course. So the benefit of attending a structured course is what? You get to learn maximum knowledge in minimum time. So everything is there. And one more thing which is exceptional, because I consider that as a boon from technology, that you can attend or you can have access to all the recorded videos by these top educators. So wherever you feel like n number of times, you can just watch these videos and learn and revise things. Brilliant thing. Now when we talk about Iconic subscription, so what are the benefits I just spoke about for your Plus subscription? Apart from that, you have got 3 extra benefits. One, you can have personal mentor. So personal mentor is like your elder brother or maybe elder sister, who would be guiding you for your upcoming next 1 year or 2 years, depending upon your package. He would be working closely with you, so in such a manner that he will be guiding you, or you can say he will be strategizing your strategy, that how to appear in the examination. Test analysis report is also there, that would tell you that how to improve the time management, how to approach the examination. It would also tell you that where exactly, in which section you are losing marks, how you can increase your positive marks so that you will have better rank. We also have study planner, so that study planner will customize the study according to your own need. It would also review your progress bi-weekly. If at all, let's say there is any change in your study plan, that change will be incorporated in next study plan. So these are the brilliant things are there in Iconic subscription. So if at all, if you look at the objective of Iconic subscription, that is just to deliver the best result from you. So I always call it what? Goal-oriented subscription. So it's a very good subscription. Now let's talk about the time period we have. So we have got 1, 3, 6, 12 and 24 months subscriptions, but I always suggest, let's say if a student is there in 11th standard, he must go for 2-year subscription, and if a student is there in 12th or he's a dropper, then he must go for 1-year subscription. Reasons are very simple. For an example, you can talk about, let's say, 11th class student. Now this is a 2 years preparation, so you would like to have the access to all the mock tests, to all the syllabus till the examination gets over, right? If at all your subscription gets over before the examination, you would feel uncomfortable. You won't feel that that confident enough when you are going for the examination, right? Second one is, since it's a 2 years preparation, so all the educators, they have designed the courses in such a manner that every single topic will be covered, having enough time in that 2 years time span. Now if at all your subscription gets over in between, you would end up skipping a few topics. Again, you will not feel confident when you are appearing for the examination because few topics are left for you, right? And third one is, it's very cost effective. Look at the price, 2,333 rupees per month. If you just look at per day wise price, what it is, 78 rupees per day. If you look at per subject wise, what it is, 26 rupees per day per subject. This is very nominal amount for India's top educators. Per subject, for a teacher for 1 day, you only pay what, 26 rupees. That's it. If you just accumulate everything, the amount what you need to pay for 2 years is 56,000 rupees. And if you apply my code NK001, the price would be reduced and the price would become what, 50,400 rupees. Similarly, for 1 year, it is 38,500 rupees. It would reduce to 34,650 rupees if you apply my code NK001. For Iconic, the price is what, 86,000 rupees, and it reduced to 77,400 rupees if you apply my code NK001. For 1 year, the price is 50,000 rupees. If you apply my code NK001, the price would become what? 50,400 rupees. That's it. Now, whenever you feel like you can buy the subscription, there is no deadline for you guys. But if you look for a suggestion, then I would say if you start your preparation ASAP, you would get better results. So it's a very simple funda. The more time you have for your preparation, the better result you would deliver. That's it. It's a very simple logic. So that says if you buy the subscription ASAP, you will get benefited. Simple. Okay. So now let me just check who all are there in my class. Lucky Senani, hi buddy, hello. कुणाल सर, यहाँ पर सौरभ कुमार सर आते थे. कुणाल आते होंगे, मुझे पता नहीं. Hi Siddharth, good evening. Lucky Senani, what is the meaning of Badla Konda? So Badla Konda, I believe it's a surname. Sometimes surnames are based on the your villages and all. Okay. So shall we start today's session? All are ready? If all are ready, just give me a thumbs up. Come on guys, give me a thumbs up. Cool. Let's start. So yesterday, if I'm not wrong, I gave you guys some questions for homework. So I want to check whether you guys attempted those questions or not. We did solve this question. We did solve this question also. We did solve this question also. And different toys. We did. Yes, this was the question in homework. Yes. What about everyone? What about Mithilesh, Siddharth? Did you guys solve this question? Tell me. Did you guys solve this question? Siddharth? Okay. So there is no update from Siddharth. Sir, could you give us some time to solve question? Yeah, Adya, you can start attempting the question. It's okay. Very good, Adya. So you can tell me the answer. Yes. Come on, guys. Lucky Senani says, sir, I'm solving. Okay. Adya says option A. Okay. So let's check. So the question says the number of ways in which we can distribute mn students equally among m sections is given by. So these students, they are not alike. They are what? Different objects, correct? So you are distributing what? Mn objects, and you made how many groups? It says equally among m sections is given by. So you made what? Equally m sections. So that means in every group, in every section, you have got how many students? N students, right? And how many sections? M sections. So how will you write n factorial, n factorial, n factorial? M times, and then you'll have what? M factorial also. So the answer is mn factorial, n factorial raised to m factorial. What did he say, guys? Other says option A was a typo. Now, this is what? This is the way to divide. What? This is the way to divide. Now, if you want to distribute among m sections, you have to multiply with what? You have to multiply with m factorial. When you do that, what is the answer? mn factorial upon n factorial raised to n. The correct answer is B. No issues. Lucky Senani, did you understand the question? What about Siddharth? Siddharth, don't you think it was a very easy question? Siddharth, don't you think it was a very easy question? Okay. Fine, Adya. Very confusing. Lucky, okay. Lucky, I would suggest you to watch my yesterday's video, because yesterday we did division and distribution of objects. It's very simple. What I can do for you is, see, whenever we try to divide, let's say n different objects are there, and you want to divide, let's say, them into 3 sections. I'm taking one example in equal size. So what we do is, we first write the total number of objects upon the size of the groups one by one, and then if at all the equal size, if at all, let's say we have equal size groups, so we take the number of equal size groups. So right now, as you can see, there are 3 groups which are having equal size, so it's 3, so we divide by 3 factorial. So this is the way, or you can say these are the total number of ways by which we can only divide these n different objects. Now division is a different thing. Now after division, if you want to distribute these groups to somebody else, so in that case you just multiply with the number of people, or the number of person, or number of sections where you want to distribute. So now I multiplied, see, as I can see m sections are being given to you, so I multiplied with m factorial because I need to distribute these m groups among m sections. So it's a very simple way. So obviously one person has m options, second person has, obviously when one group has been chosen, so the other person has got m minus 1 option. That's why this m factorial came. I hope Lucky Senani now understood. Lucky, did you understand this question now? Siddharth, what about Siddharth? Yes, too lucky. Let's move ahead. There is one more question. Find the number of ways in which 5 distinct balls. How many distinct balls are there? 5 distinct balls can be distributed in 3 different boxes if no box remain empty. So how many different balls are there? 5 different balls are there, and there are 3 boxes, and these are what? 3 different boxes, no same boxes. And now you want to just place these balls in these boxes. Now tell me the number of ways. It's a very simple formula based question which we did yesterday. I believe If you guys remember the formula, then it's cool. If you don't remember it, I can tell you the formula though. Yes, Adya. What do you think? What will be your answer? Okay, I'm waiting only. Solve the question. Lucky, you also try. Siddharth. Siddharth, buddy, you also try. What happened to Siddharth? Siddharth is very inactive today. Adya, shall I solve the question then? Okay. Now I'll solve it. It's okay. So it says that no box. Lucky says 80.00. Let's check. So it's a very, so see, look at the question. The question says that no box remain empty. What I can do is, let's find out the total number of ways by which I can distribute these 5 balls among these 3 different boxes. So you would say obviously first ball has how many options? 3 options to go. And again second ball also has 3 options. Third also 3, fourth also 3, and fifth also 3. Now let's remove those cases. Let's remove those cases when we were having boxes empty. Obviously, see, now I figured out total number of cases. Now I'm subtracting the cases when 1 box were empty, 2 boxes were empty. I'm doing this simple math. So now tell me the case when boxes were empty. Now what I can do is, the one thing is, let's say first pick out 1 box. Let's pick out 1 box which is going to be empty. So out of these 3 boxes, I pick, let's say 1. I picked 1. Now I want to distribute my 5 different balls in remaining 2. So how will I write it? So I have again 2 options for first ball, 2 options for second ball. So basically 2:5. Now tell me one thing. When I'm talking about this case, it might also happen that it is also having one case when I am having what? When I'm having this. When I'm having the second box also remaining empty. There could be a case. Right? So let's subtract that also. So when I want to subtract that from this, so again let's pick those 2 boxes. When those 2 boxes are going to be empty, then I have only 1 box. Let's place. So I placed. Simple. That's it. The question is done. Let's solve it. So 3:5. What is 3:5? So this is a 9. This is also 9. 81 into 3. What it is? 243. Correct? 9 into 9. 81 into 3. 243 minus 3C1. What will you get? You'll get 3. Correct? 2:5. 2:5 will give you what? 32. Am I correct? and this is what? This will become 3. 3 and this is 1. So let's solve this. So 2, 4, 6 minus this is 6, 9. So what is the answer here? So as you can see, 6, 6. I'll have 150 as the answer. Yes. Lucky, how did you get 80.666? What about Siddharth? Siddharth? Siddharth buddy? How did you get? Siddharth buddy, how did Siddharth? Are you not solving? Are you not being with us? It's okay, Lucky. Lucky, can you please share what was your process? Because if you can share your process, I can correct you where exactly you are going wrong. Yes, Adya, your answer is right. As you can see, I am also getting 150. I am also getting 150. Okay. So shall we move to our next question? Perfect. Let's move to our next question then. Okay. So multinomial theorem. Now tell me one thing. Why do we use this multinomial theorem? Congrats, Adya. Okay. So what is multinomial theorem and why we are talking about this theorem? So I'll tell you. So if you remember, when yesterday we were solving question when we had objects, same objects, or you can say alike objects. So let's say n alike objects, and we wanted to distribute them among our things, right? We wanted to distribute them among our things, right? So this is we were studying yesterday, right? So there, if you remember, I told you one thing. What is the limitation of that? The limitation of that is that is only valid. That is only valid when we are having what? Uniform linear equations and all, right? Correct. You can have more variables also. But in this multinomial theorem, the best way is no matter what sort of linear equation you are going to have. You can have non-uniform linear equation. What I mean to say is like this. Anything. You can still solve it. So this is, this is the benefit of this multinomial theorem. This is the basic funda why we are studying this. Now, let me just share the concept with you guys. Now, how we solve this. How we approach this multinomial theorem. So the basic funda is, let's say there is one equation. Let's say like this. And let's say it is going till xn. Hi Naraj Chatterjee. Let's say this is equal to n. Or let's make it then let's make it this as r. Okay. Now I will say that all these variables or these n, they are same, alike objects. Now what I do is I'm just playing smart. Now how I'm playing smart is, what I'm doing is just think. If I make, let's say, this sort of progression till, let's say, xn, or I can increase till infinity also, but I'll tell you. And this is for the second variable, let's say, and for the third also. Similarly for the fourth, and similarly for the rth. Okay, now just imagine if at all, let's say you are multiplying. When you multiply, all these powers, the exponents, they are getting added up, correct? Now just imagine if I talk about x raised to n, x raised to n's exponent, x raised to if I talk about x raised to n's coefficient, when the exponent of x becomes x raised to n, let's talk about its coefficient. Don't you think when it is becoming, when x exponent is becoming n, we are having different powers or different exponents from each term, from each section, right? Now these exponents are being added up. Now just imagine if I give x1's value from the exponent of this term, x2's value from the exponent of this term, x3's value from this exponent, I'll get solution of this linear equation, right? So this is the basic funda they use. Now the number of ways, if anyone wants to know, for this linear equation solution will be what? Coefficient of x raised to n will be the total number of ways. Of this linear equation. So this is the basic fundamental we use. Hi Narith, Telegram, Narith Chatterjee. What is Telegram? What do you want to do with Telegram? Narith, can you please say it clearly? Okay, I'll repeat the thing. If you have not understood this concept, the theorem, you can ask me. I'll tell you. If you have not understood this theorem, you can ask me. Then I'll tell you the concept. What I mean to say. Okay, I guess no one is doubting it, so let's move ahead. Okay, so let me just share one information with you guys also. So right now I'm writing it till, let's say, x raised to n. Now just imagine these x1, x2, x3, they can take any value more than n, any value more than n. So this will become like this till infinity. Similarly, the second term also like this. So basically I'll have how many terms? So like this, I'll have r factors, right? So if I want to write it again, so I can write it. See, this is equal to what? This is equal to 1 minus x raised to minus 1. And how many times it is? This is their rth time. So what do we get? 1 minus x raised to minus r, like this. Now if you have studied, let's say, binomial theorem, you can use binomial theorem and you can expand it. So the way you expand it, I'll write it for you guys. So this will be what? RC1 x will have then r plus 1 C2 x2. So the way you can expand it, RC, you can go till, let's say if you want to go to till n, so it will be what? R plus n minus 1, then x raised to n, C, and this will be what? Till this will be your n. Or if you want, you can write it the other way around also. It will become r minus 1 also. So it's basically same way. Okay, so that's how you can expand it. If you feel like expanding it, you can expand it like this. I hope this is readable to everyone. If this is not readable, what I'll do is I'll just rewrite this. I'll erase things. So now I'm just, why I'm sharing all these information with you guys is because you would be requiring the x raised to n's coefficient while solving questions. So that is important for you. So n plus r minus 1 c n x raised to n. Okay, Adya, Narith, hope you guys have understood this. If you guys have understood it, just give me a thumbs up. If you guys have understood it, so that's how you can find the coefficient of x raised to n. You can find out any power of x coefficient. If it is clear with you guys, just show me up. Just give me a thumbs up. Is it Adya? Because Adya, I am also watching myself live, so I can't feel any sort of glitch. So could you please check your internet connection? Okay, spamming in the chat. Um, Lucky, let's not waste time. It's better you concentrate in the class. Now, let's talk about multinomial theorems cases. Now, the very first cases when you're any variable. So let's say if I'm talking about, let's say, this sort of equation, any linear equation. What I mean to say is basically any linear equation. Now, if these variables, if these variables have maximum value more than n. So what I mean to say is, if these variables can take value more than n, then the way we are writing it, if you remember the way I was writing it like this, right? And I was writing it till x raised to n, correct? So we can go beyond x raised to n, and we can consider it as we are heading towards x raised to infinity. Why we are doing it like this? Can anyone tell me the reason why we are doing it like this? Here also we are having the same thing. So basically we are going to have till r times. We are going to have it like r times, because this is for every single variable. Okay. So this thing is what? This is 1 minus x raised to minus 1, and this can be written as like this. So basically you just need to expand this using a binomial theorem and figure out your answer. You can take x raised to n's coefficient and you can find the number of ways. Okay, now just imagine if there is a limitation. If there is any limitation on any of the variable, what I mean to say is that let's say x1 can take any value between a1 and b1, then what will happen? So just think, we are trying to find out the cases by which the exponents of x make n, right? Now the game is all about the adding the exponent of x. Now if someone says and tells you that this is the constraint on any variable, so what you need to do is, when you are writing the expansion for that specific variable, just start its power from x raised to a1 and keep continuing it till x raised to b1 in multiplication. So that's what you need to do. That's it. Simple thing you need to do, and remaining things will be as it is. What I mean to say is 1 plus x square till infinity, like this. Then again you multiply everything and find the coefficient of x raised to n to find the number of ways for the above linear equation. Okay, I hope this is clear with everyone. Now the second case is which the specific case which I talk about. Now here, let's say your variable has upper limit which is lesser than n. If that is the case, as I told you earlier also, just in previous slide, you start from, because it is all about non-negative solution. Non-negative means 0 can also be solution. So that's why we are starting from x raised to 0. So that becomes 1. So 1 plus x square. We are starting from like this. But as I told you, it has got the upper limit which is lesser than n. So better you write that upper limit here. What I mean to say is, let's say x1 can take maximum value u, and that u is what? It is lesser than n. So you'll write it here u, and rest of the elements you will write as it is, the way we wrote previously, till infinity term. This is also till infinity terms, and these are how many terms? How many factors are there? Like r minus 1 times, right? So this will be what? 1 plus x square until keep continue till x u, and this is what? 1 minus x raised to minus r minus 1. That's it. You can use your binomial theorem to open this up, and then you multiply and try finding the coefficient of x raised to n. That will give you the answer. Perfect. Okay. Now let's talk about the third case. Now the third case is, if you remember, I told you one thing, the application of multinomial theorem, that it helps us to solve your non-uniform equation. So non-uniform equation means ax plus by plus c are types of equation. Now I want to ask you something. Let's be a bit logical. Now if you think, let's say if I assign any value to x, the value will be added, or you can say the value will be added a times in this equation. What I mean to say is, if I write this equation like this, so x will be added what? How many times the same variable will be added? A times. Now again, what you can do is, you find the coefficient of x raised to n, and that will be the what? Total number of ways to find the solution. Linear equation, that's it. Here, let's go to the fourth case. Now fourth case could be, sometimes what happens, as I said, that see these variables, if you remember, when we are talking about the cases earlier, I never said this thing that that these variables cannot have same values. I didn't say this. I never said that these variables cannot have same value. Now just imagine if I come and say that these variables are having, so the values, we can say the solution. In the solution set, x1, x2 until xr, all are different. Then how to solve this question? So what I would suggest is, better we transform this linear equation into some sort of what should I say? Some sort of linear equation, but linear equation in differences. I'll try to explain you. What I mean to say is, just assume, let's say your x1, your one variable, let's say this is equal to x1. Fine. Now just assume your difference between x2 minus x1, that is b. Okay. But now this b is not equal to 0. So that means, what I'm saying is, let's say this b will have value more than 1. Because when this b is what? B is basically the difference between two variables. If I am making sure that this difference will have some finite value, more than one, I am making sure that these two variables x2 and x1, they are not going to be same. So similarly, I can assign one difference variable for my next set also, x3 and x2 variable, and I'll say that this is more than one. Similarly for this also, when I'm talking about this a, for a also I can say the very same thing, that a will be what? A will be more than one. Okay, so now what I'm doing is, now what you need to do is you just need to replace these variables in terms of, now you just need to replace these variables in terms of differences. Then the new equation, then whatever the new equation you will get, whatever the new equation you will get, that will have a constraint. What sort of constraint? Constraint will be the variables for that equation. The variables for that equation will not, we can say, will be having only positive values. They can't have 0 as their solutions. Why? Because because those are what? Those variables are what? They are basically the differences between two variables. If any difference becomes 0, what does that mean? That means you are making these two variables as equal. I hope you understood it. Hi Subhashi Pothal, #achiever. Hello buddy, good evening. I hope you guys must have understood this question. If you want, I can take an example for you guys. What I mean to say is, let's take an example. I guess that will give you good insight. So what I mean to say is, just imagine I am writing, let's say, this equation. And let's say this is equal to 10. Okay. Now I come and say that, your x1, x2 and x3, x4, they can't have same values. So what I'll do is, I'll just create differences. So I'll just make these sort of differences, the new differences variable. C will be, let's say, x3 minus x2. Let's say D is what? Your D is x4 minus x3. Now just put, now let's do one thing. Now write this equation. Now let's write this equation again in terms of difference variable. Now if you want to write in terms of difference variables, how will you write? X1 will be written as A. And one more constraint. The constraint is that your A, B, C, D. So A, B, C, D. They are going to have values more than 1. Because after all, these are the differences. Okay. So this is x1 is A plus x2 will be what? Your x2 will be B plus A. What will be your x3? X3 will be C plus x2. What is your x2? B plus A. What is your x4? That is B plus x3. What is your x3? C plus B plus A is equal to what? Equal to 10. Let's solve it. So what it is? A 1, 2, 3. So 4 A's. We have 3 B's. We have 2 C's and D is equal to 10. So this is a new equation you'll get. That's it. Okay. So this is the new equation you will get. I hope you guys have understood it. If you have not understood it, You can ask right now. I'll make you guys understand. Tell me, guys, if you guys have not understood it, we can freely ask. You are always free to ask. I guess no one has any questions, so let's move ahead. Subhashri, did you understood it? Did you understand this thing? Fine. Let's come to case number 5. The case number 5 is, this is for inequalities. What do we do? Let's say there is an inequality like this. We convert this into what? Equality. And how can we convert this into an equality? We introduce new variable, and this variable can have values more than 0. So basically non-negative values. That's it. Simple. Now it's a very simple method. We just need to follow our case number 1. Simple multinomial theorem. Right? So these are the 5 cases which you would be seeing while solving multinomial theorem based questions. So remember, when do we use multinomial theorem? Whenever we have what? We have alike objects. Remember this. So this is the only basic criteria to apply any multinomial theorem. But if you get, let's say, different solutions, so different solutions, remember this, different solution, then you go for case number 4. So having alike objects and having different solutions. But remember one thing, it is only applicable for alike objects. Solution could be different. So that is again a solution, again an application of multinomial theorem, which comes under case number 4. But still it is multinomial theorems question. Is it clear? Okay, let's move ahead then. Let's talk about this question. Try understanding this question. What does this question say? The question says, in how many different ways can 3% ABC? So there are 3% ABC having 6 1 rupees. So 6 has got what? 6 rupees. This has got what? 7 rupees. And this has got what? 8 1 rupee coin. And they want to donate 10 1 rupee coin collectively. So basically A, B, C, all 3 of them, they have certain amount. Okay. Now they want to donate collectively 10 rupees. So let's say A denotes XA coins, B denotes, let's say, XB coins, and C denotes XC coin. And the summation should be what? 10. So this is the basic problem. This is the main question. So I converted it into mathematical form. Now look at this. This comes under what? Case number 2. Why? Because every variable has certain limitation. What is a certain limitation? And in this, they have not said that no, everyone is going to donate at least 1 coin. There is no limitation like this. Let me just read it once again. Having 6 1 rupee, 7 1 rupee, 8 rupee, respectively donate 10 1 rupee coin collectively. They want to donate collectively 10 rupees coin. But there is no limitation. There is no limitation of donating at least 1 coin from each. No. So that means XA can vary from 0 to 6. This can vary from 0 to 7. And this can vary to 0 to 8. Fine. So let's formulate our problem. What sort of factors we get? We start from 0. So 1 plus x square. It will go till x6. Similarly, this will start from here, x plus x square, and this will go till x raised to 7. What about this? This will also go till x raised to 8. Now, let's use our brain. Now, what sort of brain? Can you please tell me, where have you seen this sort of factor? You remember this? I remember this. So try dividing x raised to 7 by x minus 1 minus x. Divide that. When you or I can say when you try to factorize 1 minus x raised to 7, you will find the other factor like this. See, so what you do is first you multiply with, let's say, 1, you get minus x. To remove minus x, you'll have to multiply with x. The moment you multiply with x, you get x minus x square, right? X square. So you have to remove x square. For that, what you need to do? You have to add with x square. So it will keep continue, and it will keep continue till what? Till your last term x raised to 6, because when x raised to 6 will be multiplied here, so x raised to 6 minus x raised to 7, and this is your final answer. X raised to minus 7 will be your final answer. Hi angry Prash. Good evening. So how can I write this? I can write this like this: 1 minus x raised to 7 upon 1 minus x. Similarly, I can write this as 1 minus x raised to 8 upon 1 minus x. 1 minus x raised to 9 upon 1 minus x. If you want to prove, you can prove it whenever you feel like. So now, what all factors I have got? I have got like this. One minus x raised to minus 3. Now what I'll do is, first I'll multiply these. Let's multiply these. So 1 minus 1 x raised to 8, x raised to 7, and plus x raised to 7 into 8. So tell me one thing. So do I need to write x raised to 15? Though I can tell you I do not require it, because I need to find the coefficient of x raised to 10. So x raised to 15 doesn't make sense to me, but I'm writing it for you guys so that you guys feel comfortable. Now how can I expand this? 1 minus x raised to minus 3. Very easy. Binomial theorem we can use. So 1 plus RC1. So RC1 will be what? Your 3. So 3C1 x plus your 4C2 x square, and it will keep continue. So I'll let 5C3 x cube, 6C4 x raised to 4, and it will keep continue, let's say till x raised to n maximum. I'll let till x raised to n, okay? Or shall I leave it here? That's all up to you. Okay, fine, I'll write it till x raised to n. N is what? 10 here. So I'll write it till x raised to n. So I'll have x raised to 10. Now tell me one thing, which term I'll have? See, it started when x was 1, it was 3. So there was a gap of 2. So it is 10. So obviously it will become 12, and this will become what? This will become the same. 10. Cool. And obviously you can expand it more. Now let's multiply this with this also. So 1 minus x raised to 9 minus x raised to minus 8. I'll get what? X raised to 17 also. Though I don't require it, but I'm still doing it for you guys. X raised to 7 plus x raised to 16 plus x raised to 15 minus x raised to what? 24. And this is multiplied with this same thing. Same expansion. Okay. Now, tell me one thing. Now I need to multiply and find the coefficient of x raised to 10. The final answer will be what? The main answer will be coefficient of x raised to 10. So let's pick coefficient of x raised to 10. So first I'll start with 1. Now 1 should be multiplied to which term? X raised to 10. Then only I'll get x raised to 10. Correct? So 1 will be multiplied to x raised to 10. So this is the coefficient first. So 12C10. Now x raised to 9. So x raised to 9 should multiply to which term to make it x raised to 10? Obviously with x. So this x raised to minus x raised to 9 should be multiplied to this term. So I'll multiply with this 3C1. So this will be the coefficient. Cool. Now let's talk about x raised to minus 8. This should multiply to x raised to 2 term. Then only we get x raised to 10. So when it multiplies, what coefficient we get? We get this minus 4c2. Cool. Now 17, obviously 17 if 17 will multiply to any x raised to something, obviously we get more than x raised to 10. So let's not multiply, let's not waste time. So that's why I was saying there is no point writing the terms which are having more power than 10. Clear? Let's talk about x raised to 7. Now this x raised to 7 should multiply to what? X raised to 3. Then only we get what? X raised to 10. So if it multiply to this thing, this will be our coefficient 5c3. Cool. Now obviously now suppose that we have higher degree terms, x raised to 16, x raised to 15, x raised to 24. We don't need to just find out their coefficient because we don't require. So what is 12c10? 12c10 will be what? 12 minus 12 into 11 by 2 minus this is 3. This is what? 4c2 is what? 6, right? 4 into 3 divided by 2, 6. And what is this? This is 10. So this will cancel out 6. 66 minus 19, right? This will give what? 47, correct? 47 is the answer. So guys, 47 ways. So there are 47 different ways by which these ABC can donate. ABC can donate your donation, 10 rupees coins. Cool. I hope you guys have got it. Angry, Prash, Adya, Subhashi. Are you cool with it? If you're cool with it, just show me a thumbs up. Give me a thumbs up. Come on guys, give me a thumbs up. Cool, Varun Raj. Great. So let's move ahead now. Okay, Varun, try attempting this question. Read the question. The question says, in how many ways can 15 identical blankets? How many? See, I told you, multinomial theorem can be used when we have identical objects. And you can see identical, alike objects. So in how many ways can 15 identical blankets be distributed among 6 beggars? So there are how many beggars? 6 beggars. Such that everyone gets what? At least one blanket. Basically, okay, let's read the first question and completely, then we'll make the equation. And 2 particular beggars get equal blankets. 2 particular beggars, they get what? Equal number of blankets. And another 3 particular beggars get equal blankets. Okay, so let's form the question and see what sort of question we make. Varun, are you trying the question? If you're trying the question, then I'll wait. Otherwise, I'll start the solution. Varun, you want to try it out? Or you want me to attempt the question? Varun, I don't see. Okay, Varun, let me tell you one thing. See, I don't remember the answers because it's not like this. You know, I mug up the answers. We can solve. I can solve with you, and then we can just check. Okay, cool, perfect. Let's check. Okay, so 15. Okay, so how many beggars do we have? We have got 6 beggars. So let's say every beggar will get x1 blanket, second will get x2 blanket, third one will get x3, fourth one x4, fifth x6, like this. And this should be equal to what? 15. Now what it says is that at least one blanket. So that means your x1, x2, x3, x4, x5, x6, everyone is more than what? 1. So whenever we are going to expand, remember this fact. We'll start from x. Remember this. Okay. Now let's read the other constraint. The other constraint says is 2 particular beggars get equal blankets. So I distributed, let's say 6 here. 2 particular beggars get equal blankets. Okay, and another 3 particular beggars get equal blankets. So 2 get equal, then remaining 3 get, okay, and 2 particular beggars get equal blankets. So if you just see the question, now what they have done is they have indirectly said to us is that x2 is what equal to, let's say, x3, and x4 is equal to what, x5 equal to x6. This is what they have said. So now what will be our new equation? Our new equation will be what? x1 plus twice of x2 plus thrice of x4 is equal to 15. Now this is what they have said, right guys? So this is what they have said. So now what it is now non-uniform equation. Now we have spoken about this non-uniform equation, right guys? So how to play with this equation now? Very simple. So how will I write the expansion now? For first variable, I will write the expansion like this: x1 plus x square plus x cube, and let's say till infinity, because there is no upper limit given, so I can increase it. So I know upper limit is limited, but still. Now this is x twice of x2, so that means I'll have to introduce like this: x square, x squares, x squares cube, and again this will continue till infinity. Then we'll have what? X cube square, x cubes, and again it will go till, let's say, infinity. Now for this expansion, what do we have to find? We have to find when we get x raised to 15. So basically we have to find what? Coefficient of x raised to 15. That is our basically main need. If we find out that, that will be what? Total number of ways by which we can distribute the blankets. Okay. So let's do one thing. First, we'll just write these terms once again. What I'll do is I'll play smart. Why I'm saying I'll play smart? I'll just pick out. Let's say x common from this term. When I take x common from this term, and when I take, let's say, x square common from this, it becomes x cube. When I take x cube from here, it becomes what? X raised to 6. So what I have? 1 plus x, x plus x square until infinity. I have got this as 1 plus, again, x square, x raised to 4, x raised to 6, like this, and this is there till x raised to, 1 plus x cube plus x raised to 6, x raised to 9, x raised to 12, x raised to 15, like this. Okay, so I hope this is clear with everyone. Now that's all up to you. If you want to play smart, we can play smart. What we can do is we can just find what? We can find the binomial expansion and we can just multiply. We can find it. Otherwise, if you don't want to do it, we can simply multiply. See, now we have to find the coefficient of x raised to 15. X raised to 6 we have already taken common, so that x raised to 6 will be multiplied to every single term by default. So in a way, for this expansion, I just need to find, if I want to talk about, I just need to find what? Coefficient of x raised to 9, correct? X raised to 9 only. So let's find out the coefficient of x raised to 9. So let's do one thing. Let's multiply. Let's start from this term. So let's see how can I make x raised to 9. So I'm just writing all the equations here. So let's say if I start with 1 here. If I start with 1 here, so 1 is basically 0 power. 0 power. Now from this, if I, let's say, again from take 0 power from here also, then I have to multiply with what? X raised to 9. So basically 9 power from there. So this could be one case. Plus, let's talk about another case. I am starting again from 0 from here, but from here I can't take 0, I can't take 1 directly, I'll have to jump to 2. If I jump to 2, can I take 7 from here? No, because 7 is not available here. So this is not possible. Then I can take x raised to 4. If I take x raised to 4, then I have to take x raised to 5. X raised to 5 is also not available in the third factor. So can't do. I can then take x raised to 6. If I take x raised to 6 here, then I can take x raised to 3 here. So this could be one way. So again, I'll get 1 only as coefficient. Perfect. Can we take any other thing? No. Then from here we'll have what, x raised to 8. So x raised to 8 can't multiply to x because x is not available in your next term. So let's check this. So these are the possible cases for 0 power. Let's talk about power number 1. When I take power number 1 from here, which power I can take? Let's say if I take 0 from here, so 1, 0, I should have 8 from here. No, I can't have 8 from the third expansion. Sorry. 1 power from here, that means x from here, and if I multiply with x square, yes, so the remaining x raised to 6 I can get from here. So this is one more way. Plus x, let's say 1 power from here, and if I take 4 from here, it becomes 5. I can't take 4 from here. Third, no, not possible. X raised to 6 if I take from here. So x into x raised to 6, x raised to 7, x raised to square. So square term is absent here. I can't play with that. Then I can take from second term x raised to square. So x raised to 8. So if I take x raised to 8, then I can multiply this with 1. So I can take 0 power from here. One way. Cool. Now let's go to our next power 2. When I go to our next power 2, so I can multiply with, let's say, 0. So I need 7 from here. No, that is not possible because 7 is not available in the third term. If I go for square, no, I can't take 7 from here. Not possible. Sorry, 5 is not possible. If I go for 7, if I go for 4, yes, then 3 is possible. Then 3 is possible from there. So it becomes one case. So if I having square from here, then 6, 8, I can't have 1 from there. Then I directly have 8. That will increase. So only one case for 2, 4, 3. Let's go for now power number 3. If I go for power number 3, what do I see? If I go for power number 3, so I can multiply with 0, and then I can directly go to 6. So I have one more way. So I have 3 from here, 2, 5, 4, I can't take. 3 from here, 4 from here, 7, 2 can't have. 3 from here, 6, yes. 3, 6, 0. One way. Okay. Now, then 3, 6, 0, obviously more than I can't do. So let's pick 4 from here. If I pick 4 from here, so 4, 0, 5 not possible. 4, 2, yes, 4, 2, 3 is possible. So one way. 4 from here, then 4 from here, then 1 from, no, not possible. 4, then 10. 4 and 6 will become 10. So obviously we don't need to worry about that. Let's go for 5. If I pick 5 from here, then I have 0 here. I can't take 4 from here because 4 is not available here. Then if I take 5 from here, 2 from here, 7, then 2 is not available. I can take 5 from here, 4 from here, yes. 0 I can take from the last term. So this is one more way. 5, 6, it will become 11, so I can't take. So now from this first term, let's take 6. If I take 6, I can take 0 from here and 3 from the last. That is possible, so I'll have one more case. Plus, I'll have 6 from here, 6 from here, then 2, 8, 1 I can't take from there, then 4. So obviously no 6. Then I have only 7 left. If I pick 7 from here, then I can have 0, but 2 can't from the third term. 7 from here, 2 from the second, yes, then 0 I can take from the last. So one more case. Plus, then 7, 2, 7, 4, it will go 11. I can't do anything. Then I have 8. If I take 8, what will happen? 8 from here, Then 0 from here, 1 I can't have from third. Then directly 2. So 8 is also not possible from the first term, from the first expansion actually. Now I have what? Which option? 9. If I take x raised to 9, then I can take 0, then I can take 0. Yes, the only last option. So how many options are available? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 options are there, buddy. One Raj, 12 options are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 options are there. It's not 11, it's 12. Varun, I hope you have understood this. Have you understood this question? Varun, if you have understood it, just give me a thumbs up. I have done it in a very simple manner so that you can understand, because every single case has been shown here. Varun, are you there, Varun? Subhashiri, Varun, Adya, Siddharth, Narith. Are you guys there? Okay, let's move to our next question then. Before the next question, we have got something. Hi Mitlesh. Okay. Before the next question, we have got something to learn. Now, what is this D arrangements? So this D arrangements is, I'll try to explain what it is actually. So just imagine you have got n different things. So corresponding to these n different things, you have got, let's say, n envelopes or n boxes or something like that. So what I mean to say is n different things. So each of these n different things, they perfectly fit in these n boxes or n envelopes. Okay. So now just imagine if I arrange these n different things such that any of these n things goes to its corresponding box or envelope. What I mean to say is, for say I have second number of object. Now second number of object has got, let's say, second number of box. So instead of going to second number of box, it can go to other boxes. So I'm talking about those cases when it is not going to box number 2. So it is applicable for every box till n. So nth number box will not go, so nth number thing will not go to n number of box. It will go to something else. So this is applicable for every thing. So the formula, the number of ways what we get is, that is n factorial 1 minus 1 upon 1 factorial, then 1 upon 2 factorial, minus 1 upon 3 factorial, plus 1 upon 4 factorial. It will keep continue. You keep continue till minus 1 raised to n factorial. So this will continue till like this. Okay. So this is the basic formula for your D arrangements. Okay. Now, if you have understood it completely, you have understood the concept. So I would request you guys to, let's solve a question. The question is this. Read it. The question says, there are 4 balls of different colors. So there are 4 balls of different colors. So let's say color number 1, color number 2, color number 3, color number 4. And 4 boxes of colors same. So same boxes. So color number C1, so same color box for 3, same color box for 4, and same color box for 4. Find the number of ways in which the balls, so these balls, one in each box. So in every box there should be one ball, could be placed in such a way that a ball does not go to box of its own color. So again, don't you think it's a rearrangement question? So every ball has got corresponding box, but in this question you have to find total number of ways when this C1 ball will not go to C1 box, it will go to some other box. So this is not applicable, only these are applicable. So similarly for C2 also. So basically it's a simple question of rearrangements. So how to find it? So here n is what? N is 4. So let's apply the formula. So 4 factorial into what? 1 minus 1 upon 1 factorial plus 1 upon 2 factorial, 1 upon 3 factorial plus 1 upon 4 factorial. That's it. Till here, because we can't go beyond this. You have to write it till n factorial. So this is 1 minus 1, this will cancel out. So finally we'll have 4 factorial. 4 factorial will multiply to, let's say, let's multiply also. 4 factorial will multiply to 2 factorial, so 24. This is 12. This is 4 plus 1. So what are the total number of ways? So we have 9. So 9 is the answer for total number of rearrangements. Okay. So this is your answer, final answer. Clear, Varun? Cool. Hope you have understood the question, Varun. Perfect. Cool. Great. Let's move ahead. Okay. So now these questions I have left, if at all you guys have. So now our permutation combination is done. If you have any questions, let's say in your sheets or in your daily practice problem, you are always free to ask. You can ask, I'll solve it for you live right now. If not, then I'll pick few questions from the book itself and then we guys can sit and solve those questions. Okay. So I've got one question. It's a very good question. I'll write it for you. The question is, there are n straight lines. And n straight lines in a plane in which no two are parallel. So none of them is parallel. So that means they'll intersect for sure. So no two are parallel. And no three pass through the same point. And no three are collinear. So collinear means basically concurrent, actually concurrent. Basically no three are passing from one point. So this is what it means. Okay. Their points of intersection are joined. Now whatever intersection point they made, now those points are being joined. Now we have to show that the total number of fresh lines thus introduced. Now we have to find the number of fresh lines. Number of fresh lines formed using the intersection point. Okay, so this is the question. Come on guys, let's find out. Yes, it was very easy actually. Let's solve this question. So what are you going to do? So we have to find the fresh lines. First, let's do one thing. Let's find the total number of intersection points. Because once we know the total number of intersections, I know there are n straight lines. To find the intersection point, I have to pick two straight lines. So once I get two straight lines, whenever they'll intersect, they'll make one intersection point, right? So NC2 will give me what? Total number of intersection points. So what it will be? n minus 1 by 2, correct? Okay. Now, since I have got these intersection points, so now these, let's say if I pick those out of these intersection points, if I pick any 2 points, I can make a line, right? So number of new lines out of n minus 1 by 2 points, right? So that will be what? N into n minus 1 by 2 c 2, correct? So this will be what? This will be n minus 1 by 2 factorial upon 2 factorial n minus 1 by 2 minus 2 factorial. So how will I write it? I'll write it like this: n minus 1 by 2 into n minus 1 by 2 minus 1 upon 2. Simple. So as you can see, 1 by 2, 1 by 2. So I can pick a 1 by 8 common here. Now first term n minus 1 as it is. Let's solve this. If I solve this, so it will be what? N square minus n minus 2. So if I try to factorize this, what will I get? 1 by 8 n minus 1. N I can take common. If I take n common, so this is n square minus 2n plus n minus 2, right? So how can I write it? Like this only. Correct, guys? Right? Is anyone having any doubt? If you have any doubt, you can always ask. Clear? So I'll have what? N multiply n square minus n. Like this. Right, guys? So this is what I'll have. Okay. So now tell me one thing. What I did is I picked. So these are the new intersection points, right? So it might also happen. Just think. It might also happen that I might. What I'm trying to say is try to understand this, because this is something very important for you guys. See, I'm having, let's say, these two intersection new points. If I join these two intersection points also, I'll have what? I'll have the same line, right? Which is already there, present. So what I have to do? I have to subtract those lines also, correct? Hope you are getting this. See, what I'm trying to say is, what I did is, so far what I've done is, out of those intersections, I have picked those lines also. See, it might also happen, what I mean to say is, see, let's say 3 lines are there. So as you can see, there is one intersection point. Now I'm trying to, let's say one more intersection point. Now we are trying to form these new lines. But these two intersection points, if they join again, they can form the same line, don't you think? They can form the same line. So we have to take those cases out. So how can we take those cases out? Tell me. How can we take those cases out? It's very simple. Out of those lines, I'll pick again those same lines. So whatever the same lines I'm getting, I'll pick them out. So how can I pick them out? I have to just simply subtract. So how can I subtract? Minus n into nc2 by nc2. What I'm doing is, I'm just assuming, because every line, see, every line is going to be intersected how many times? Apart from this one line, other lines will intersect it. So n minus 1 lines will intersect it. So that's why n into n minus 1 lines become there. So let's reduce this. When we'll reduce this, we'll get our answer. So the what we'll have 1 by 8 n minus 1 n plus 1 here minus n. So this will be what n minus 1 into n minus 2 upon n minus 1 upon 2 by it. Correct. So I can take what n minus 1 n minus 2 as common. So I'm left with what? I'm left with this n plus 1 by 8 minus n by 2. So I can write it as 4n by 8, right? So if I solve it further, these are the common terms. If I solve it further, so what do I get? 1 minus, so this is 8. Correct. So I can have this minus 3n, 1 minus 3n by 8. So 1 by 8 will be common. N into n minus n minus 1. These are the common things which I took common out. Sorry, my bad. See, I have taken n minus 1, n minus 2 common. There is only 1 by 2, only 1 by 2. So this is 4 by 8. So if I solve it further, so what do I get? 1 by 8 is common. N minus 1, n minus 2 is n plus 1 minus 4. So n minus 3. So this is the total number of lines you will get. Okay guys? Have you guys understood it? Varun, did you guys understand this question? Varun, did you guys understand this question? My battery is about to die. Okay. What about other guys? Varun, number of octagons that can be formed by using. Okay. Just give me a moment. I'll have to write the question before my battery goes down. Number of octagons. So octagons basically you have to pick 8 sides. That can be found by using vertices of 20-sided polygon. Okay. So we have 20-sided polygons. Basically we have got 20 vertices. Such that no side of octagon is common with side of polygon is given by NCR1 minus NCR2. Then minimum value of R1 plus R2 is equal to. Have I written correctly, buddy? Can you please tell me, have I written correctly? Can you please confirm with me? Have I written correctly? This is what the problem is. Then you have to find the minimum value of R1 and R2. Varun, can you please confirm it, because my battery is about to die, so you need to confirm it right now before I solve it. This, okay. No side of octagon is common with the side of polygon. Okay. So in a way, what we are going to do is, obviously you can say that out of 20 vertices you are going to pick 8 here. But when you pick 8, so basically you will form all the octagons. But we have to subtract the octagons which are having what? Common sides. Common sides. So what I mean to say is, let's just imagine if I have one common side. If I have one common side, so if I have chosen one common side, so I have to choose, I have to pick what? 6 more vertices, because I have got already 2 vertices. I have to pick leftover 6 vertices. Because the moment I'll pick leftover vertices, I can form my octagon. So it's about picking up these 6 vertices. But tell me one thing. From this, I have to subtract It says octagon is common with sides of polygon is given by. Now I'm talking about the case when only one side of the octagon I'm picking. One side of the octagon is common. So in that case, I'll have what? 20 sides, 20 pairs are there. Then I am assuming obviously, so adjacent thing I can't take, because adjacent if I'll take, so obviously I'll have what? How many sides common? I'll have 3 sides common. So 20. Then left over these one vertices. I can't take these vertices, so I have to choose what? Out of 16. 2, 4, 16. I have to pick 6. Then I can make one octagon. Similarly, I have to pick when I can have 2 sides common. Don't I think that will become lengthy process. What could be smarter? See, Varun, one way, as you can see, one approach I have shown you. So what I have done is, when one side is common, I am reducing this case. When exactly one side is common, okay, you add when you can take 2 sides common. When you take 2 sides common, 1, 2. So how many pairs you can create? So exactly you can create 20 pairs. You can check, because luckily I know this fact. So let's say I have made what? 1, 2, 3, 4, 5, 6, 7, 8. If I created octagon, so how many pairs, adjacent side pair I can create? 1, 2, 3, 4, 5, 6, 7, and this is 8. So 8 adjacent pair. So using this way also we can just solve this question. But I'm thinking about something else. What I'm thinking is, see, right now I created the octagon minus. So it's like I have got sides. It's about picking up the sides. Now at least one side should be picked up. Because yes, Varun, Varun, I am also thinking about the shortcut. Because I know, because the answer we are getting it in terms of NCR2. So I am also thinking about the shortcut. Because this is one of the basic way, the very easiest way to solve it. I am also thinking about one shortcut. 20C8 is clear that it is the total number of octagons. The number is when I can have at least one. When I can have at least one out of these 20 sides. I am going to pick at least one. So when I'm choosing, total number of selection. When I'm going to pick, so I can go to each side. And I can ask yes, no, yes, no, yes, no. So 20 raised to 2 raised to 20 minus 1. So these are the total number of ways, but this is for different objects, correct? And I'm considering different, and if I go to alike things, if I go to alike things, then how many ways we can in how many ways I can pick? So I have 20 ways. I have 20 ways by which I can pick. So let's consider all these sides are same. All these sides are same. So if I consider them same, I'm dropping this out. I'm considering them as same. So I have 20 options when I'm picking at least one side. So when I'm picking at least, so when I can pick one side common, when I can pick two side common, when I can pick three sides common, multiplied with Varun, my phone is shut, so just be there online because I can't converse. So what I'll do is I'll open YouTube tab here. YouTube tab here. So I can see your comment here. So I can. Okay, buddy. So if you leave any comment, I'll read it here. What can we do? I'll just read your question. What it says. Number of octagons that can be formed by using vertices of 20-sided polygon such that no side of octagon is common with the side of polygon is given by NCR1 minus NCR2. Then the minimum value of R1 plus R2 is minimum value. So minimum means obviously R1 has fixed value. It's about R2. R2 should have maximum. So R2 should be maximum. Okay. No side should be common. No side should be common. I think, see, now Varun, right now it seems that we have to solve it like this only, and we have to make cases. When one side is common, then 20, 16, C6. When two sides are common, so you can pick any two sides out of these 20. Out of these 20 sides, you can pick any two sides. So how can you pick it? So it's very simple. So 20 C2, you pick two sides. When you pick two sides, so you have to make sure that you are not going to pick what? Adjacent. You can't take adjacent vertices. Clear? You can't take adjacent vertices, otherwise that will involve third side. So in that case, what will happen if you take, let's say, any two? 1, 2, 3, 4. So obviously you can't pick these 4 points. Sometimes it might also happen that you have, let's say I make this adjacent side also. So in that case, we have only 2 points. You have to consider that also. Wait a minute. Shortcut. Varun, can you think of something else also? 20 C2, then picking two sides. Two sides. Yes, that we can do. I can play smart. What I can do is first I'll pick, let's say, one side into. Now I'll pick the second side which is adjacent. If I'm picking adjacent side, so I have only two options. So adjacent side. So either I can pick one, this one or this one. When I pick these two adjacent sides, then how many points I can't choose? I can't choose. So 1, 2, 3 points are already being chosen. 2 I can't choose to get into this. So total I have what, 5 points. So out of 15 points I have to choose now how many points? I have already 3 points for the octagon. So now I have to pick only out of 15. I have to pick only what? How many points? Only 5 points. So this is one specific case. Second could be 20 into what? If I'm choosing randomly, two sides, if I'm choosing, let's say, randomly any two sides, so 20 into, obviously it can't be adjacent. When it can't be adjacent, so this I have chosen. So you can't take this one or this one. So that means how many sides are left for you? You are left with 17 sides. Now you are left with 17 sides. Now you are left with 17 sides. So how many points you can take? 1 point, 2 point, 4 points actually. It might also happen. It could be 4 points, 3 also. 4 points are left. Then already 4 points, 16. So you are left with what? 1, 4, 4, 8, 8, 12. So one case 12C, 12C, 1, 2, 3, 4, 12C, 4. But again, this is a very lengthy process. Even I also understand this is not the way to solve the question. As in, this will take time. Octagon is common with side of polygon is given by NCR minus NCR value of R1 plus R2. When any of the side is common. Varun, are you there? It's okay. No, it's okay. I know. You also think about something. So I picked only the cases minus when sides are common. All the possible selections. I can have any number of minus when any other side is common. Varun, I would say I'll also think about this question. What you can do is you can come tomorrow. Tomorrow we'll discuss about this question. Okay. I'll also think there is some. I think there should be some property which is which will solve the question. Or maybe what will happen? Maybe we'll get this term, a bigger term. bigger term, but that will simplify to a shorter term. It might also happen. It might happen that we'll have this sort of thing. I'll also think about this question tonight. Okay. So we will have our session till now. So I would take your leave now, and I would like to inform you guys about my fun day series. I am conducting a fun day series on Unacademy application. You guys can come there, where what we do, we try to solve difficult questions using the basic fundamentals. And whenever, what you can do is, you can first come to the Unacademy application, follow me there, so that whenever I conduct any free special live class, you get notification for the same. Okay, so you can come to the Unacademy application, follow me there first, and if you have liked the video, then I would request you to just press the like button. You can subscribe the Let's Crack JEE in English channel. You can also use my code NK001 if you're planning to go for plus or iconic subscription, and you can press the bell icon button. So if you press bell icon button, you'll get all the notifications for your for all the videos which are going to be live on Let's Crack JEE English channel. Okay, so I'll take a leave, and Varun, tomorrow I will be solving your question. Whatever doubt you have posted, we will be solving your question. And I would like to I would like you guys to make a note that tomorrow's session will be more of problem based questions. So whatever we have studied so far in permutation combination, we'll be solving many problems based on this chapter. Okay, so I'll take your leave, guys. Bye bye, take care, good night.